Hello and welcome. Today we are going to learn about bisectors and the segment addition postulate. First, we'll learn what a postulate is, because you probably haven't learned about them yet. A postulate is a type of statement, like a theorem, but the difference is that a postulate hasn't been proven yet. It is just something you must accept to be true. On the other hand, a theorem is a statement that has been rigorously proven using other theorems or postulates. Now, the segment addition postulate, which declares that if you break a straight line segment into smaller pieces, the lengths of those smaller pieces add up to the total length of the original segment. This likely seems pretty obvious, but it still hasn't been proven as it's a postulate. First, we can use this to find the lengths of segments using other lengths, which we will try now. Here, we are given the lengths of two parts of a line segment and tasked with finding the whole, which we know we can do by adding because of the segment addition postulate, which in this case we add 8 and 3 to find 11. Same deal here, but we must subtract this time. The postulate still applies though, just in reverse. So we subtract the part, or 5, from the whole, or 11, to find the other part, which will be 6. These types of problems won't always just be one step though, so let's take a look at one that isn't. Here, we are given a whole and two parts, and tasked with finding the final part. First, you should always label everything you're given. We can see that we want to remove the two side parts by subtracting, so 16 minus 4, which is 12, and then 12 minus 5, which is 7, and that's our answer. You will not always be given this diagram, so it's important to understand how to translate the problem into math, or you could draw your own diagram, which I strongly encourage. Now let's visit a type of problem that you will see a lot in geometry courses, which is doing algebra with geometric rules. For these, you always want to write some sort of equation from the information so that you can solve for the variable. In this case, we are given both parts and the whole, but a variable is tangled in them. So let's write an equation to match it. Using the segment addition postulate, we can add the two expressions for the parts and set them equal to the expression for the whole. Doing so gets us this equation, which you should know how to solve at this point. If you need a refresher, visit my videos on the first unit in this course, which will come out soon. After solving this equation, you should get x equals 7. The algebra you have to do in these problems will not always be so simple though. You could have to solve something as complicated as a polynomial equation for now, and the difficulty will scale as you learn more algebra. So next, we will solve one that's a system of equations. This may look very complicated, but let's notice that the left 3 and right 3 points don't really interact besides being straight. So let's rewrite the equations from each side separately, starting with the left, where we can add the two parts and set them equal to the whole. And for the right 3, we can do the same thing to get another slightly simpler equation. Now we can do substitution, and we should substitute y instead of x because it is already isolated. Substituting gets us this equation from the left one, where we can now solve for x to get 2, which we can then plug into the right equation to get -1, which together forms our answer of 2, -1. Again, if any of the algebra just done is confusing, you should go watch my videos on systems of equations in the 4th unit of this course, which will probably come out eventually. Moving on to the second half of this topic, we will discuss bisectors. But you shouldn't have even heard of them yet, so what are they? Well, a bisector is a line that splits another line segment or angle into two equal parts, and the verb form of the word is bisects, which will be used quite often. For now, we will focus specifically on segment bisectors. The other type will be covered in another topic. And a segment bisector, as you could probably guess, is just a bisector that bisects a segment rather than an angle. Here is an image of one. The red tick marks are used to signal that the two line segments are congruent or equal. Do note that they can be any color, they are just red here. We can be certain that line CD bisects line segment AB because of the red tick marks. Otherwise, it would be a guess, which is a big no-no in geometry. It's not shown here, but the line segments are only necessarily congruent to the other segments with the same amount of tick marks. So a segment with 2 tick marks would only be congruent to other segments with 2 tick marks, not just 1. Now that we understand bisectors, there are a few more things to discuss before we do a practice problem, starting with midpoints, which is the point precisely in the middle of a line segment. The midpoint of a segment also happens to be the point a bisector will intersect with a segment. However, even line segments that don't have a bisector will have a midpoint. Next are perpendicular bisectors, which are a subclass of segment bisectors that are also perpendicular to the line segment, creating a right angle at the intersection. We can draw a right angle using this box to denote perpendicular lines with an upside-down T. To finish this video, let's do a problem using segment bisectors. Here, we know an expression for a whole and one part, but because we know the part ends at a bisector, we can conclude that the other part must be equal to the part we have. So, we can set the whole equal to 2 times the part and solve, which, if done correctly, will yield 4 as the solution. That's all for this topic, so let's do some comprehension questions to help you remember. Pause to try them out. And here are your answers. Thanks for watching. I hope you enjoyed and learned something. See you soon.